Hello students, welcome you all to the video lecture on chapter number 9, Mensuration, exercise 9.1, question number 10. The question is, there is a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita divided it into two different ways. So this is the Jyoti's diagram, this is Kavita's diagram. Find the area of this park using both the ways. So we need to find out the area by using the Jyoti's diagram as well as Kavita's diagram, and then can you suggest some other way of finding its area? If any other possibility is there, that also we need to suggest. So coming to the Jyoti's diagram first, the pentagon has been divided into two parts by dividing it symmetrically. So this part separately, this part separately. When we see this, we can see that is we have here one trapezium, and then another trapezium is looking like this. Okay, so symmetrically they are dividing this pentagon into two different trapeziums. And then coming to the Kavita's diagram, they are dividing this pentagon into a triangle and then followed by a square. So they are dividing it into triangle and then a square. So if we find the area of a trapezium 1 and area of a trapezium 2, when we add both the things, we can obtain the area of a pentagon for Jyoti's diagram. And then if we find out area of a triangle and then area of a square, and then we can add it and we can find out the area of a pentagon by using the Kavita's diagram. So coming to the Jyoti's diagram, so here the measurement is 15 meter, here also 15 meter, here also 15 meter. The overall length is nothing but 30 meter height of a pentagon. So these are all the measurements given in the problem itself. So we are dividing that into two trapezium, that is this is one trapezium, this is one trapezium, and the measurement here it is 15 meter and the overall height is nothing but 30 meter. And then we know that generally just view the diagram in the horizontal manner, just rotate and view the diagram. So how it will be? So the diagram will be look like this. Okay. So when we rotate this diagram will look like this. And what is the measurement for this? This is 30 meter and this part it is 15 meter. Okay. When we go to the formula for a trapezium, we need the height also. Okay. So we need the height of a trapezium. So what is the height? Height is given by this measurement. This is the height of a trapezium. Okay. So coming to the pentagon, this is the height, but coming to the trapezium, this part is the height. Okay, so this is the height of a trapezium. So I need to measure this height. Already they have given that this is 15 meter. Since it has been symmetrically, it has been separated, I can say that this is 1/2 of the 15 meter. So equally divided 1. So 15 meter when I divide by 2, it is 7.5. So this side it is 7.5 meter. Similarly this part it is said to be 7.5 meter. So I can take the height as 7.5 meter. So divide 15 by 2 and check that it will be of 7.5 meter. So all the values whatever required for the trapezium, it is there in the diagram. So this is A, that is length of one parallel side, this is B, that is length of another parallel side. And then coming to the formula again, area of a pentagon is area of a trapezium 1 and area of a trapezium 2. And since it has been symmetrically divided, when we find out area of a trapezium 1, definitely area of a trapezium 2 also will be equal. Why? Because the parallel side length here also 30 meter, here also 30 meter, here also 15 meter, here also 15 meter. Here also the height is what? 7.5 meter. Here also the height is 7.5 meter. So in simple, I can say that area of a trapezium 2, it is equal to area of a trapezium 1 because both are having the same measurement. So I can rewrite the area of a pentagon has area of a trapezium 1 plus area of a trapezium 2 is also what? Area of it is equivalent to area of a trapezium 1. So instead of writing 2, I can write it as T1. So 2 times it is trapezium 1 is repeated. So it is 2 into A of T1, right? So A of T1 plus A of T2, it is what? 2 into A of T1. So 2 into, what is area of a trapezium? It is 1 by 2 into, general formula it is what? 1 by 2 into A plus B into H. So this is the general formula. So this part alone is the area of a trapezium. Okay. And here 2 times the area is repeated. So I can write it as 2 into this value. So coming to the formula again. So 2 into 1 by 2 into, what is A? A value it is 15. And what is B? B value it is 30. And then what is H? H it is 7.5 meter. So just simplify this. So 2 get cancelled. And then I have 15 plus 30. 15 plus 30 is what? 45. 45 into 7.5. Just multiply these two values. So 45 into 7.5. So 5 5s are 25. Here it is 2. 5 4s are 20. 20 plus 2 it is 22. 7 5s are 35. Here 1 3. 7 4s are 28 plus 3. It is 31. So 5, 7, 3, 3. Okay, since before one value you have decimal point, so before one value I have to put the decimal point. So the value it is 45 into 75, it is what? 7.5. 45 into 7.5 it is what? 337.5. And then the measurement it is in meters. So this is in meter, height also in meter. So meter into meter it is meter square. So area of a pentagon according to the Jyoti's diagram it is 337.5 meter square. So coming to the second part, that is Kavita's diagram. So Kavita is viewing the pentagon in the form of triangle and then a square. So I can write the area of a pentagon, it is equal to area of a triangle plus area of a square. So in order to get the area of a triangle, we know that it is half into base into height. Here it is the measurement, it is 15 meter. So definitely this part also will be of 15 meter. So base is given by 15 meter and we require the height. So height is not given directly. So we need to find out the height of the triangle in order to apply in the formula. So the overall measurement it is what? 30 meter. So this measurement is 15 meter. So definitely this is what? 30 minus 15. So we need to subtract these two values. So the overall height is 30. This height is 15. So just subtract both so that I can get the height of this triangle. So 30 minus 15 is what? 15 meter. So the height of the triangle is nothing but 15 meter. And then coming to the square, all the sides are equal, right? So all the sides are of 15 meter. So we can now apply for the formula. What is the area of a triangle? Half into base into height. What is the area of a square? Side into side. So 1 by 2 into, what is the base? 15. What is the height? Height is also 15. So 15 into 15 plus, what is the side here? 15. Another side is also 15. So I have 1 by 2 into 15 into 15 it is 225 plus 15 into 15 it is 225. So here you have one 2. So just divide, 2 table we can apply, 2 ones are 2. Here 2 ones are 2. Again 2 ones are 2. 2 twos are 4. Balance is 1. Okay. So that we have to put one decimal point. So it will become 10. 5 twos are 10. So either you can directly find out or you can do the simplification like this. So whichever is easy for you, that you can do. So put the decimal point here, 1 0, 5 twos are 10. So 10 minus 10 get cancelled, so we will get 0. So 112.5. So 112.5 plus 225. So add these two values. So when we add these two values, what are the values? 112.5 plus 225. Here there is no decimal point, so leave that. So here only 0.5. Here 5 plus 2 7, 2 plus 1 it is 3, 2 plus 1 it is 3. So the overall value it is 337.5. Again Meter into meter, it is meter square. Area of a pentagon is 337.5 meter square. Previously also we have obtained the same value. Okay, and then coming to the question. So area of this park using both the ways. Both the ways we have determined, both the ways we are getting the same area. Can you suggest some other ways of finding its area? So what are the other ways of finding the area? And again, so this pentagon, in another part, I can divide the top triangle into, that is this I can symmetrically divide like this. Like that also I can find out the area. That is, so this is one triangle, this is one triangle, and then below you have one square. So like this also I can split your pentagon into 3 parts. Instead of dividing the 2 parts, I can split your pentagon into 3 parts. Okay, and then I can find out the area also. So this is the another way of finding the area of a pentagon. Okay, so area of a triangle 1 plus area of a triangle 2 plus area of a square. Like that also I can split your pentagon. Thank you. Thanks for watching.